Okay, so in this video, we're going to look at calculating the geometric distribution probabilities using a TI-84. Now, the geometric distribution is a discrete distribution and is referring to a sequence of Bernoulli trials. Again, Bernoulli variables are what we're essentially using in the binomial distribution, where we have only the options of success or failure. And here we are going to calculate the probability of needing X number of rolls until we get the first success. So we're essentially looking at the probability that we have X minus 1 failures and then a success. So failures in a row. Unlike a binomial distribution, there's not a fixed number of trials. We stop counting whenever we get to that first success. So how many rolls of a standard, how many flips of a standard coin do I need in order to get the first head, for example? Or how many rolls of a standard die do I need before I get a 6? So the geometric distribution is related to the hypergeometric distribution, but the hypergeometric distribution is not in the TI-84 calculator. The geometric distribution is. If you want to use the hypergeometric distribution, you would need to go to the formulas and use the counting formulas that make up the hypergeometric distribution. But we do have a nice formula built in, a function built in for the geometric distribution. Now, older calculators may not have this. So the TI-84 does, but older calculators may not. Now, the geometric distribution, again, we get all of our distributions from the distribution menu, which is second, and then the vars key. So it's the one next to the clear button on your calculator screen. And there are two geometric distribution functions way down at the end of the list, the geometric PDF and the geometric CDF. Again, because this is a discrete distribution, you can use either or both depending on the specific problem that you're doing. So the PDF will come up with a discrete value for exactly 5 rolls before you get a 6, for example. The CDF will be up to 5 rolls, up to and including 5 rolls before you get a 6. Again, for example. So we'll look at an example of each one. So suppose we want to calculate the probability that it will take exactly 4 trials before the first success, if the chance of success with each trial is 30%. So this is exactly 4 trials, so we're going to use the PDF. And then, again, this is using the classic mode rather than the stats wizard mode. You'll call up your PDF function, and you'll have to specify in this order the probability of success and then the number of outcomes that you want. And the number of trials you think it will take in order to get there. And then when you enter this, the calculator will calculate that probability. And again, press enter. Now, if you want the CDF, what if we wanted to know that it would take no more than 4 trials to obtain the first success? So either in 1 attempt, 2 attempts, 3 attempts, or 4 attempts, but not 5 or more attempts. Then again, we would call up the CDF because we're adding up a bunch of things. And then we would put in I have this syntax backwards. We would put in 0.3 for our probability of success and 4 for the number of outcomes. Typing 0.3, 4. It's close. It should be 0.7599, not 0.784. Don't mess up your probabilities and your counts, obviously. But the syntax is always going to be the probability and then X in both of these cases. So unlike the binomial, you don't have to specify the number of trials because you're just going until you get this first success. So the number of successes you're always looking for is 1. So you don't need to specify that. X is as if your number of trials, you're going until you get that first one.